This lecture covers numerical problems on psychrometric analysis of Hvac. So most of the examples are related to calculation of heating loads, calculation of cooling loads, and calculation of the capacity of humidifier. That is the process of humidification and dehumidification process. So this numerical problem and example will also explain how to draw the state point and how to find the other parameters for the solution of numerical problems relating to design of HVAC system with the help of psychrometric charts. Exercise problem 1. An air conditioning plant is handling 30 cubic meter of air per minute at 32 degrees Celsius temperature, that is dry bulb temperature, and 22 degrees Celsius wet bulb temperature. If the final condition of air are 22 degrees Celsius dry bulb temperature and 50% relative humidity, find the capacity of humidifiers. So this is a psychrometric chart where point number 1 and point number 2, the state points have been drawn, and the process line, because in this question we need only the value of humidity ratio W1 and W2, and we can see that against the point 1 and 2 on the vertical axis we have calculated the value of W1 and W2, and these only two parameters are required, and also the specific volume is required for this value. And at point number 1 we can also calculate the find the specific volume, and these three values are only needed with the help of psychrometric charts. So first of all, we will record the outside condition and inside condition. The outside condition, the given values are dry bulb temperature 22, relative humidity 50%, and inside condition are to be maintained. Dry bulb temperature 32 and wet bulb temperature 22 degrees Celsius. So from these 2 points, we will draw the point on psychrometric chart. So volumetric flow rate is given as 30 cubic meter per minute, and we will also calculate the specific volume with the help of psychrometric chart, which comes to be 0.882 cubic meter per kg. So capacity of humidifier is to be calculated, and the formula for the humidifier is the M prime into change in humidity ratio W1 minus W2. So from psychrometry, W1 was calculated as 0.01249 kg per kg, and W2 was calculated as 0.00822 kg per kg. The specific volume also already explained 0.882 kg per minute. So the mass flow rate is calculated by dividing the volumetric flow rate with the specific volume, which is 30 divided by 0.882. It comes to be 34.0136 kg per minute. So the capacity of humidifier M prime into change in humidity ratio. So we have put the value 34 into 0.01249 minus 0.00822. The answer comes to be 0.14629 kg per minute, or 8.7 kg per hour. So this is the moisture removal rate. Actually, the capacity of humidifier, this capacity of humidifier would be required under this condition. Exercise problem 2. A cinema hall of seating capacity of 1500 has been provided with an air conditioning plant with the following data. Outdoor condition 40 degrees Celsius dry bulb temperature and 20 degrees Celsius wet bulb temperature. Inside conditions 20 degrees Celsius dry bulb temperature and 60% relative humidity. Amount of air supplied 0.3 cubic meters per minute per person. If the required conditions is achieved first by adiabatic humidifying and then cooling, find the capacity of cooling coil and capacity of humidifier. So this is the psychrometric chart where point number 1 and 2 have been drawn, and from this point 1 and 2 we can calculate the value of enthalpies and humidity ratio, that is W1 and W2. Amount of air to be supplied is equal to 0.3 cubic meters per minute per person. As there are 1500 persons in this numerical problem, so the total volumetric flow rate required is equal to zero point 0.3 into 1500 is equal to 450 cubic meter per minute. Now from psychrometric chart, enthalpy and specific humidity against 40 degrees Celsius dry bulb temperature and 20 degrees Celsius wet bulb temperature, the enthalpy was found to be 56.83 kilojoules per kg and humidity ratio W1 is equal to 0.00645 kg per kg. Enthalpy and specific humidity against 20-degree dry bulb temperature and 60% relative humidity. So H2 is determined as 42.28 kilojoules per kg and humidity ratio W2 as 0.00873 kg per kg of dry air. The specific volume was calculated as 0.8963 cubic meters per kg. So the mass flow rate will be calculated by dividing the specific volume, volumetric flow rate by specific volume. So it is equal to 450 divided by 0.8963 is equal to 502.06 kg per minute. So for the capacity of cooling coil, the formula is m prime into H1 minus H2. So putting the value here, and the capacity of cooling coil comes to be 34.78 tons of refrigeration. And capacity of humidifier is equal to m prime into change in humidity ratio. So by putting the value, the capacity of humidifier is found to be 1.1447 kg per minute or 68.68 kilojoules per hour. Exercise problem 3. An office hall of 70% capacities is to be provided with summer AC plant with the following data. Outside condition 35 degrees Celsius dry bulb temperature and 26 degrees Celsius wet bulb temperature. Inside condition 20 degrees Celsius dry bulb temperature and 40% relative humidity. Amount of air supplied 0.3 cubic meters per minute per person. Find the sensible heat factor of the plant. So from the data, point number 1 and point number 3 have been plotted over there. So this is the process line actually. And for the sensible heat factor, we will resolve this line into rectangular component in order to calculate the sensible heat factor for sensible and latent heat. So we can see that, so 3 points will be formed, 1, 2 and 3. So 1 to 2 point will be the latent heat because the temperature will remain constant, and point 2 to 3 will be the sensible heat point. And the formula for sensible heat factor is equal to sensible heat divided by total heat, that is sensible plus latent heat. So mass flow rate is equal to volume flow rate divided by specific volume. So its value comes to be 21 divided by 0.898, so 23.385 kilojoules per minute. Draw rectangular components from the given points along x-axis and y-axis to meet a third on psychrometric chart and record enthalpies on these points. Enthalpies of the horizontal line represents sensible heat, while enthalpies along vertical line represent latent heat at constant temperature. So H1 was found to be 80.1 kilojoules per kg, H2 50.14 kilojoules per kg, and H3 is found to be 34.83 kilojoules per kg. Also recorded specific volume as 21 cubic meter per minute. Latent heat by using the formula m prime into h1 minus h2 was found to be 701.94 kilojoules per kg, and sensible heat by using the formula m prime into h2 minus h3, and its value comes to be 358.22 kilojoules per kg. Total heat, sensible heat plus latent heat, 1060.1632 kilojoules per kg. And sensible heat factor formula is sensible heat over total heat, that is the sum of sensible and latent heat, and its value comes to be 0.34. It's unitless. Exercise problem 4. The amount of air supplied to an air-conditioned air is 300 cubic meter per minute. The atmospheric conditions are 35 degrees Celsius dry bulb temperature and 55% relative humidity. The required conditions are 20 degrees Celsius dry bulb temperature and 60% relative humidity. Find out the sensible heat and latent heat removed from the air per minute. Also find sensible heat factor for the system. So for the sensible heat factor, first of all, we will draw the state points and the process line 1 to 3, and then we will resolve this process line into rectangular component 1 to 2 and 2 to 3. So 1 to 2 will represent the latent heat and 2 to 3 will represent the sensible heat, and we will record the value at the enthalpy axis from psychrometric chart. So from psychrometric chart, the value of enthalpies at point 1, 2 and 3 have been determined. H1 is equal to 85.47 kilojoules per kg, H2 is equal to 57.32 kilojoules per kg, and H3 is equal to 42.28 kilojoules per kg. So specific volume at point number 1 is also calculated as 0.901 cubic meter per kg, and the mass flow rate is found to be 300 divided by 0.901 is equal to 332.92 kilojoules per minute. So the sensible heat is equal to m into h2 minus h3. By putting the value, the sensible heat was found to be 5007.71 kilojoules per kg, and the latent heat formula is m is equal to latent heat is equal to m into h1 minus h2. So by putting the values, the latent heat is equal to 9372.82 kilojoules per kg. Actually, this is these values were calculated as explained earlier, that by resolve the process line, it's in the form of a diagonal into rectangular component. So the line which is parallel to y-axis, it will have the constant temperature, will give the latent heat, because the definition of latent heat, it is the amount of heat energy which is required to change the phase, and the temperature will remain constant. So the horizontal component will be the sensible heat. So it is the amount of heat energy required to raise the temperature from one temperature to other temperature, in which definitely rise in temperature will take place. So the horizontal line, the temperature will be changing, it will be the sensible heat, and the vertical line will be the latent heat. So we have found out these two values, sensible heat and latent heat, and the total heat is equal to sensible heat plus latent heat. It is equal to 14380.534. So the sensible heat factor is equal to sensible heat divided by total heat, and it comes to be 0.348. Exercise problem 5. An auditorium of 300 seating capacity is to be provided with AC with following data. Outdoor conditions 12 degrees Celsius dry bulb temperature and 70% relative humidity. Indoor conditions 20 degrees Celsius dry bulb temperature and 50% relative humidity. Amount of air supplied 0.25 cubic meters per minute per person. Find the heating capacity of the coil. So from the given data, draw the point 1 and 2 on the psychrometric chart and find the values of enthalpies. So similarly, this problem can be solved because the formula for the heating coil is M prime into change in enthalpy. So we will find the values of enthalpy between the 2 points and also the specific volume in order to convert the mass flow rate, volumetric flow rate into mass flow rate. So by recording only the two values of enthalpies and one volume of specific volume against point number 1, we can calculate the capacity of heating coil as explained in this numerical. Exercise problem 6. A restaurant with a capacity of 100% is to be air conditioned with the following conditions. Outside condition 30 degrees Celsius dry bulb temperature and 70% relative humidity. Desired inside conditions 23 degrees Celsius dry bulb temperature and 55% relative humidity. Quantity of air supplied is 0.5 cubic meter per minute per person. The desired conditions are achieved by cooling, dehumidifying and then heating. Determine number 1 capacity of cooling coil in tons of refrigeration, capacity of heating coil and amount of water removed by the humidifier. So we have drawn 2.1 and 3 on psychrometric chart which are given state condition. So but the condition of the problem is that first by cooling, then by dehumidifying, then by heating. So point 1 to 2 prime is the cooling, 2 prime to 2 is the dehumidifying and 2 to 3 is the heating process. So we will have to calculate all the points for the cooling, dehumidifying and heating. It will be explained in the next slide. So from psychrometric chart, H1 found to be 78.21 kilojoules per kg and H2 37.94 kilojoules per kg, W1 0.0188 kilogram per kg of dry air and W2 0.00964 and H3 is found to be 47.64 kilojoules per kg and specific volume is recorded at point number 1 and its value is 0.885 cubic meter per kg of dry air. So the M prime will be calculated by dividing volumetric flow rate by specific volume. It is equal to 50 divided by 0.885 is equal to 56.49 kg per minute. So power of cooling coil will be recorded between point 1 and 2 because the cooling is done by two processes. Cooling plus dehumidifying is the cooling process actually. So is M prime into H1 minus H2. So putting the value, the power of cooling coil was calculated to be 2274.85 kilojoules per minute. And we will divide this value by 210 because 1 ton of refrigeration is equal to 210 kilojoules per minute. So the answer comes to be 10.8 tons of refrigeration. Power of heating coil M into H3 minus H2. So it is equal to, by putting the values, and answer comes to be 547.95 kilojoules per minute. So the power of heating coil in kilowatt is equal to 9.1 kilowatt. Water removal rate M into change in humidity ratio, and by putting the values at point 1 and 2, the answer comes to be 0.51744 kg per minute or 31.05 kg per hour. These are the assignment problems to be solved by the students. Assignment problems, page 2. Psychrometric chart in metric units, RSI system. Another psychrometric chart, 1500 meter above sea level in SI system. Psychrometric chart in FPS system, where we have temperature, Fahrenheit, and pound system.